What I thought quite pertinent, seeing that I touched on the aspect of those questions on the inside of our back cover, I thought, let me just run through some of these very briefly and ask yourself whether you can answer them. And there's no reflection on you in a detrimental way if you can't. They're just quite interesting questions that stimulate a hell of a lot of interesting dialogue. So, the difference between a virus and a bacteria, and why this is important. Well, it's quite important because a bacteria has a metabolism, responds to antibiotic treatment. A virus doesn't have a metabolism, hence it doesn't respond. It's also quite different in its morphology, or the way that it's made. And a virus is very specific for a certain type of tissue. However, I'm not going to go into the genetic differences right now. Why are antibiotics effective against bacteria but not viruses? Well, we've covered that. Why could it be known as a genetic disease? It's a bit of a controversial question why it could be known as a genetic disease. The outside shape of your white blood cells has corresponding receptor cells that the virus can lock onto. If by any chance those are genetically changed through a mutation, obviously the white blood cell can't lock onto it and therefore cannot infect the cell. That's the first reason why it could be called a genetic disease. The second most important reason that I believe is that the virus makes its way into a cell. From there it makes its way into the nucleus, which is found in the inside of the cell. From there it makes its way and it integrates itself into your genome or your DNA. Alright, it has to change from an incompatible form of RNA, which is a genetic material found in a virus, to a compatible form of DNA found in your white blood cell. So the whole replication process takes place in your genome. So in the broadest sense, it could be known as a genetic disease. Why is an understanding of the rudiments of genetics, DNA, RNA, important in understanding HIV? Well, I've just very briefly explained that, and that is most important, that 99.9% people have never been taught. Why does it have spikes protruding? Well, we touched on that. Without the spikes, it can't lock onto a white blood cell. If it can't lock on, it can't infect. Now, why does it have spikes? The reason being is that a white blood cell has a positive net charge. The HIV/AIDS virus has a positive net charge. And what happens if you bring two positives together, like the opposite ends of a magnet? They repel each other. So what the virus has actually done is it's developed these spikes that allow it to latch on without getting too close. And in other words, it won't be repelled. Quite an ingenious little beast. What is a CD4 cell and what group of cells does it belong to? Well, it's one of the white blood cells. It's one of the lymphocytes, and there's many different types. That is just one. Why can mosquitoes not transmit HIV? It's a little bit of a lengthy discussion, but they're not flying hypodermic needles, and there was some experiment that said you had to be bitten by something like 10,000 mosquitoes that had simultaneously fed on an HIV/AIDS positive patient before it can possibly infect you. But also, the mosquito needs a way of propagating the virus. Other forms of diseases that are spread by mosquitoes requires the virus to get up into the mosquito, into the salivary glands, where it can be propagated or amplified. In the HIV/AIDS case, it can't infect any of the mosquito cells, so it cannot be propagated. But there's a bit of a more lengthy discussion on our website around that. Why is a vaccine difficult to develop? That's quite lengthily described on our website. If a mother was HIV positive, would her baby automatically be infected? No, not at all. The baby might be might test HIV positive after birth, but it doesn't mean that it's HIV positive. All it means is that the baby has inherited some of the mother's antibodies, and the HIV/AIDS tests against the antibodies. As soon as these dwindle off in the baby will revert to being negative again. That's quite interesting. And what are antiretrovirals and how do they work? Well, very briefly, they just disrupt the whole replication process and assimilation of the viral components after replication. So after it's replicated, all the little components are put together, they form a virus. if you can cut off one of those processes, an incomplete virus is formed. Some of the antiretrovirals are also being developed to actually stop the virus from even entering the cell, which is a better way of combating it right in the beginning. Where did HIV/AIDS originate from? Well, there wasn't any surreptitious relationships between a monkey and a human, as many people do believe. It's also a long process, but an interesting point is you get a simian immunodeficiency virus, which is found in apes and primates, and you get a FIV, which is a feline immunodeficiency virus. They both cause few flu-like symptoms in their respective hosts, and at this stage it doesn't seem to be able to cross the genetic barrier. However, if one of those had mutated and made its way into a human, possibly a hunter, and sort of propagated on from there, that's a possible way. But it's quite a lengthy description and topic of where it originated from. I hope you enjoyed those questions, and lots more on our website.